you're to use Green's theorem to evaluate this function around this boundary, and I've copied the formula for Green's theorem from a formula sheet. You have it here. Alright? Now I want you to write this down and then complete it. Pause the video, write it down, complete it before you watch the remainder of the video. Okay, you're finished. Let's look at the question together. Now, here, Green's theorem formula says when you have the integral around a closed curve of m dx plus n dy, well, usually I say p dx plus q dy, but just letters, it doesn't really matter whether you want to have m dx plus q dy or a dx plus b dy or whatever it is. That is equal to the double integral around the region of partial of n, partial of what multiply the y by partial x minus partial of what multiply x by partial y. So you see they're switched around. Alright? Minus minus that. And then dA. dA means the area. It could be dx dy or dy dx. Okay? Now, you could work it out dx dy or dy dx depending on which one is more convenient to you. But let us see what's going to happen here. Look at this. You see m is this part. Or let me write the formula the way I'm more comfortable with. I mean the way I've known it before. Instead of m and n I use p and q. So it's the integral around a closed curve of p dx plus q dy is equal to the double integral of the thing that multiplies the y, in this case is n, but in the case here is q. So is partial q by partial x minus, and then partial p by partial y. Now they have dA here. I will use dx or dy first. Let me write dy dx. Okay. Now looking at this, what is p and what is q? Well, in this case, p is xy squared minus x squared. So p is xy squared minus x squared. Q, or in this case n, well, my p would be m. I use n here. In my case q, n is, or q is 4x minus 1. That's q. Now I have partial q by partial x would be equal to, when you differentiate this with respect to x, you get 4. Okay. Partial p by partial y is what? When you differentiate this with respect to y, you get, well, differentiating with respect to y would be 2 times xy. 2xy. Alright? See that? Make sure you're following up. Now we have the double integral. Now the double integral of partial q by partial x in this case 4 minus partial p by partial y, in this case 2xy. Okay, let me use dy dx. Now what that means is that I'm going to integrate with respect to y. So I need to look at the boundaries and see what's happening here. You have negative 3 here, so negative 2, negative 1, you have 0 here. Let me just highlight these. 1, 2, 3. Now this line here, this line, we need the formula for it. Rise over run is what? It rises from 0 to 3, which is 3, and it runs from negative 3 to 0, right? Which is 3. It's 3 high and 3 long, so the gradient is 1. And it cuts the y-axis at 3. So it's a straight line with the formula y is equal to 1x plus 3. Alright? So you can see that. Now, the reason why I want the formula for it, because I want to know where y starts and where it stops. Now look at this. I want to integrate with respect to y first. What are the boundaries of y? How does y change? If I should stack these small elements with the width delta y and the height delta x. I mean the width delta x and the height delta y. If I should stack them up along y, I would go from, they would start from y equals 0. All of them would start from y equals 0. So this is going from y equals 0 to where? When I go up and up, it would stop from at the line. If I stack these up from here, they would stop at the line. If I stack these up and up, they would stop on the line. So they go from y equals 0 to y equals x plus 3. To y equals x plus 3. Alright? Now, I had stacked 3 lines of them, 3 columns going up. But I need to fill the entire circle. Then not a circle, the entire triangle. So I'm going to change x. Now, if I should stack these things, I would have to start from x is negative 3. Right? So stacking them up. Now remember, if I were integrating with respect to x, I would have to transpose this and start from x is y minus 3 going to the right to x is 0. But I'm not doing that. I already integrated with respect to y and stop at the line. Now here, if I stack them up from floor to ceiling, right, y is going from the floor at 0 to the ceiling at y equal x plus 3. X is going from this corner at negative 3 to the right to this wall at x equals 0. Right? I don't need to worry about how high these x are being stacked because that was taken care of already. When I say they go from y equals 0 to y equal x plus 3, I just need to pile up the x's from left to right from negative 3 to 0. Alright? So these would stop at 0. So when I fill out the entire thing, once the entire triangle is filled out with all of these elements, I know that it goes from x equals negative 3 to x equals 0. So it goes from x equals negative 3 to x equals 0. Okay, so you see that? Now, here you have this being integrated with respect to y. Alright? So this is 4y minus 2x y squared over 2. Alright? And goes from y equals 0 to x plus 3. Now, I write back the integral from x equals negative 3 to x equals 0 dx. I'm just integrating with respect to y now. The integral with respect to x is not touched as yet. Now here we have the boundaries, putting in the boundaries. Let me just write back the integral from x equals negative 3 to x equals 0 and then put in the boundaries. It's 4 y, but guess what? Y is going to be x plus 3. So, alright, 4 x plus 3. See that? It's 4x plus 3 because y is equal to x plus 3. Y is equal to the upper boundary minus, and then y is equal to the lower boundary, right? Y, I'm dealing with the upper boundary now. So it's 4 times the upper boundary y, which is x plus 3 minus 2 times x times the upper boundary again, x plus 3. Y is x plus 3, but y is squared, so this must be squared. See that? Right? Over 2, but if I put over 2, 2 cancels 2, so I would need to worry about that part. I can leave off the 2 part here. Okay, minus, open bracket. The lower boundary is 0. So it's going to be 4 times 0 minus 2x times 0 squared over 2. And 2 would cancel 2. But guess what now? Dx. But guess what now? This part is going to be 0. So I have the integral from x is negative 3 to x is 0 of. This is going to be 4x plus 4 3 is 12 minus, let me put a bracket here, x plus 3 squared. Right? So remember, it was y squared over 2. Right? So it's x plus 3 squared. Oh, my. It's not open bracket. It's not minus open bracket. Okay, it is minus x, then open bracket. So it's x plus 3 by x plus 3. Right? Minus 0. This part amounts to 0. Alright? Dx. So what we want to do is to simplify this part, and then we integrate with respect to x. We'll keep writing the integral sign and the boundaries. Alright, don't forget it. Alright, so we have 4x plus 12 minus, okay, what's going to happen here? We have x, open bracket. We need to multiply out the x plus 3 part. We're going to be x times x which is x squared plus 3x plus 3x, going to be plus 6x plus 3 3's 9, okay, dx. Alright, so you can write the dx a little nearer. But have the x to multiply it out again. So you have the integral from x equal negative 3 to x equal 0 half. So you have 4x plus 12. Now it's going to be minus x times x squared is x cubed, minus x times 6x is going to be minus 6x squared, minus x times 9 is minus 9x dx. Oh, alright. So we have all of that. You can just finish off simplifying and then finally do what's going on? Yeah. Why this thing jump all the way up here? This thing. Let me go back. Yeah, and then finally complete the integration. Alright. So we have the integral from x equals negative 3 to x equals 0 half. Alright. Let's put this negative x cube first, highest power first, minus, and then 6x squared, and then 4x minus 9x is what? Negative 5x, alright, plus 12 dx. Whoa, alright. So that's what we have. Let's do our integration now. You run out of scrolling space, you know. Can't scroll up anymore. But anyway, we continue. We have negative x to the 4 over 4 minus 6x cubed over 3 minus 5x squared over 2 plus 12x from negative 3 to 0. Alright, so we can't scroll down anymore, so let's just draw a line and work on the other side of that line. Oh, that line. Alright, let me just put the dx nearer to here and continue the line. Alright, so it's going to be guess what, instead of rewriting all of this thing again, I'm just going to copy it and paste it up here. Alright, so okay, so let's work with this now. So upper boundary substituted for x first. X is equal to the upper boundary, which in this case is negative 0 to the 4 over 4 minus 6 times 0 cubed over 3 minus 5 times 0 squared over 2 plus 12 times 0. And you know all of that will be 0, alright? Minus, okay. Now this part is going to be negative. Then x is negative 3. This negative is this negative, you know. And then this one is this one. Alright? Negative 3 to the power of 4 over 4 minus, and 6 times negative 3 cubed over 3 minus 5 times negative 3 squared over 2 plus 12 times negative 3. Good. Now, this is 0. So it's 0 minus all of this that's going to happen here now. What is negative 3 to the power of 4? Now 3 3 is 9, 9 3 is 27, 27 3 is 81. It is 81. Positive 81. So this negative here become positive because there are 4 of them multiplied. But this negative still remains. So it's negative 81 over 4. Alright? Minus now. Now 3 in the 3, 1, 3 in the 6, 2. So it's going to be 3 times negative 3 cube. Negative 3 cube is what? 3 3 is 9, 9 3 is 27. And it's a negative 27. So this is 2 times negative 27. Alright? So it's minus 2 times negative 27. We'll fix that up later. Minus 5 times, well, negative 3 squared is positive 9. So it's minus 5 times 9 over 2. Alright. 12 by negative 3 is negative 36. So minus 36. Okay. Now, this is a negative open bracket. Negative 81 over 4. Now 2 times 27 is negative by negative, which gives you a positive. So this is going to be plus. 2 7 14, bring down the 4, carry 1, 2 2s 4 and 1 5. 54. Right, this part is a minus. 5 9 is 45. This is 45 over 2 minus 36. When you open the bracket, remember the negative outside the bracket is like a negative 1 multiplied by each term in the bracket. So they will become positive. So it's positive 81 over, they will change sign. The negative will become positive, the positive will become negative. It's a positive 81 over 4 minus 54 plus 45 over 2 plus 36. Okay? What will all of that amount to? Well, in this case, we could work it out as fraction, but let me use my fractions calculator. My on-screen calculators don't have that feature where they work out fraction. But I have a fraction calculator here with me. 81 over 4 minus 54 plus 45 over 2 plus 36 equal 99 over 4. It's 99 divided by 4. So that is our answer.